Are the scientific calculations in the movie Interstellar accurate? What is the speed of the spacecraft and what is its size? How does the passage of time change near a black hole? What does impulse look like inside? In this video, we look back at the journey of the characters in the film, trying to verify the accuracy of different concepts from a mathematical perspective, and recreate some of the visual effects in the film. This may be a bit technical, but don't worry, even if you don't understand every calculation. Still available from, get inspired by the overall story. In this story, emergency on Earth, food shortage. The air is almost unbreathable, dusty. The planet seems no longer suitable for human habitation. In this doomsday scene, former NASA pilot Cooper, living with 2 children, but in daughter Murphy's bedroom, some strange events happened. Cooper ultimately identified these events as gravity anomalies and revealed the coordinates to a secret NASA base. It seems that some mysterious force is trying to guide them to find this base. We learned there was an impulse near Saturn, to other possible stars to colonize. NASA is preparing to launch a critical mission. Let astronauts travel through time, visit 3 alien stars with potential to live in the world. As a former NASA pilot, Kubo was recalled at this time. After joining this adventure takeoff, crew goes into hibernation. It will take spacecraft 2 years to reach near Saturn. Is this time reasonable? By considering the distance between Earth and Saturn and the assumed orbital radius, the speed of the spacecraft can be roughly estimated. The distance between Earth and Saturn is about 1.3 billion kilometers. If the flight time is 2 years, the average speed of the spacecraft is about 70,000 kilometers per hour. For comparison, Apollo 10, the fastest manned spacecraft in history, had a speed of about 4 hours per hour, thousands of kilometers. Assuming that future interstellar technology is more advanced than our current technology, it is reasonable to reach the vicinity of Saturn within 2 years. To keep the crew comfortable during the journey, the spacecraft will use the centrifugal effect to provide artificial gravity. Designed as a rotating ring structure, push the crew towards the outer wall. According to the backslash in the formula, 2 backslash is the radius of the spacecraft. T backslash is the rotation period of the spacecraft. In the movie, the half period of the spacecraft can be calculated to be 5.7 seconds. The total period is about 11. For seconds, does not produce the same 9 as the Earth. 8 meters per square second of gravity. The radius of the spacecraft should be approximately 30 meters. The diameter is about 60 meters. This size is quite realistic, because the radius of the International Space Station is about 70 meters. As the spacecraft passes through the impulsive vicinity of Saturn, the crew awakens and observes this space-warping passage for the first time. A wormhole is a conduit connecting 2 regions of the universe. Its surface is 3-dimensional. Both sources and light can pass through it. Images from the other side can also be sent back. But how realistic is the wormhole shown in the movie? Simulate to find out. We start with a cylinder connecting 2 spaces. Transition it smoothly to achieve the effect that film director Nolan hopes to present. Choose a camera angle. Place 2 images representing the starry sky on either side of the wormhole, allowing light to reach the camera directly or through a wormhole to reach the. We use ray tracing technology. Send a ray through each pixel of the camera and trace its path to determine where it comes from in the sky and what color it reaches the camera. This is effectively equivalent to using the side-ground wire equation. That is, the equation of general relativity. By tracking curved space-time trajectories, images can be obtained pixel by pixel. When combining them dynamically, the simulation results are very similar to the visual effects in the movie. We can try to change the geometry of the impulse. Explore what if Nolan had gone with a different design. What will it look like in the end? For example, longer impulses allow light to travel several times before reaching us. In this way, you can see the repeated images of the universe between the stars. After the spaceship Neri traveled through the impulse, the scene inside unfolds before our eyes. Simulated footage from the show and the visual effects team on the film. It may not necessarily be different from what the audience understands. In fact, this simulation could produce intoxicating images. After this exploration team passed through the wormhole, arriving near the supermassive black hole Gargantua. Black holes are surrounded by planets. The crew's first target is the planet Miller. This planet is very special, completely covered with water, and its orbit is very close to the black hole. Affected by the strong tidal forces of Gargantua, the gravitational pull on one side of the star is significantly greater than the other side, causing huge 1-kilometer high waves to form on its surface. Due to proximity to black hole, every hour that passes on the star, 7 years have passed on the Earth. This time warp and giant waves make Miller's planet even more mysterious. Scientist Kip Thorne pointed out, the height of the wave exceeds 1 kilometer. We can try to roughly estimate the distance between a star and a black hole to form such waves. These waves are actually tidal phenomena created by the black hole's gravity. Tides similar to those produced on Earth by the moon's gravity, but on a much larger scale. Although the waves in the movie are thinner and higher than regular tides, but we can still use the combined effect of tidal forces and centrifugal effects caused by planetary orbits to reasonably explain this phenomenon. Within the framework of Newtonian physics, we can calculate the strength of the tidal force. This force causes the water to move between low and high tides. Each drop of water gets a certain energy by multiplying the vertical displacement and the average value along the path. This is the energy brought by tidal forces. So let the water rise. The gravitational energy it acquires must be equal to this energy. Consider a black hole with a mass of 1 million solar masses. If a planet about the size of Earth orbited it, then the orbital distance of the planet should be 4.5 billion kilometers. To ensure comparison with the black hole's starshield radius, by enlarging and comparing this proportional relationship, we can deduce its diameter is approximately 300 million kilometers. In movies, depiction of a planet called Millis, it orbits a black hole called Gargantua, shows strong time dilation. That is, every hour is equivalent to 7 years on Earth. This time dilation is approximately that of a static black hole. The time experienced by a planet in a circular orbit is slowed down by a factor of 60,000. However, orbital distance calculated from tidal forces. This calculation result only applies to static black holes. However, general relativity allows black holes to rotate, spin faster, the more likely there is a stable orbit near its horizon. This calculation result only applies to static black holes. However, general relativity allows black holes to rotate, spin faster, the more likely there is a stable orbit near its horizon. Although this calculation is more complicated, but we can be sure that if the planet's orbit is 6,000 kilometers from the horizon, and the rotation speed of the black hole is only 0.000 slower than the speed of light. Although this is extremely fast, it is not impossible in theory. There are still differences between the plot in the movie and the real physical situation, but the visual effects of black holes do attract widespread attention. French scientist Jean Allen conducted relevant simulations as early as 1979, but in 2014, for the first time we saw such a realistic image of a black hole in a theater. This black hole is spinning at a speed close to the limit allowed by general relativity, allows us to trace the trajectory of light, determine their origin. Some light is blocked by black holes, resulting in the corresponding pixel being unable to access light, thus forming an image of a black hole. The gravitational lensing effect deflects light, produce visual distortion, allows us to observe the shadow of a black hole. For static black holes, the shadow appears disc-shaped, but in a rotating black hole, it appears squashed, because the rotation of space and time drags the light. Gargantua in the movie, there is an extremely bright disk of plasma surrounding the black hole. In the simulation, the image of the disk is distorted by the black hole's gravity. Make its back appear folded. This will cause the ship to be destroyed instantly. Therefore, the temperature of the suction disk is lowered in the movie. Make it thinner. Lower internal pressure. The suction disk rotates at high speed around the black hole, leading to the Doppler effect. Light on one side is accelerated. The other side is slowed down. So we see a slight blue color on one side of the suction plate. The other side is dark red. When an interstellar mission returns to Earth, Professor Perfect's mathematical model try to explain this problem. This assignment helped him solve a complex equation. The goal is to find answers about the nature of gravity and use this new knowledge to build a massive spaceship, send humans into space to save the future. At this stage of the research, Professor Brand concluded, believes that gravitational anomalies must be caused by something outside our universe. He proposed that our universe may be part of a larger space, and this larger space has one more dimension. Gravitational anomalies may be caused by fields that exist in larger space. In the movie Interstellar, we can see Professor Brand's blackboard showing the details of this model. This universe contains 3 branes: the one we are in, the one above, and the one below. These 3 branes form a sandwich-like structure. The geometry of the entire universe is twisted into reflexive geometry. This geometric structure allows the distance above and below to be extremely stretched, making it difficult to escape gravity. In our universe, gravity spreads in all directions and is distributed on the sphere, so its intensity is inversely proportional to the square of distance. But if we add an extra spatial dimension, gravity is no longer limited to the sphere. Instead, it extends to the hypersphere and decays in a cubic manner. However, due to the existence of antitheistic geometry, this gravitational distortion does not significantly increase distance. The additional 2 brane gang leaders limit the range of distortion. It also provides enough space for exploring the 4th dimension. The accuracy of this model justifies the film's ending. Returning to Earth, M.O. Fay took over from Professor Brand and continued to study gravity. His task is to find the solution to the equation and describe the nature of the field to explain anomalies observed on Earth. Although the professor's model initially seemed very promising, but no final answer was given. Finally, realizing that the professor already knew the key they needed, but it was not revealed. They need to understand the quantum nature of gravity. To complete the model, he had to figure out what exactly happens when gravity meets quantum physics. This requires reaching deep near the black hole's origin. And that's exactly what his father, Joseph Cooper, did when he followed the crossing star in another galaxy. When Cooper breaks away from the Nelly and falls into the world of black holes, can he survive without being trapped? In the 1960s, the scientific community generally believes that the starting point of a black hole is a point. However, by the 1970s, scientists realized these starting points exhibit chaotic, twisted structures. In the 1990s, these chaotic starting points were called BP starting points. Researchers discovered that when matter falls into a black hole, due to time dilation effect, the relative motion of falling matter appears to slow down and continue to accumulate, eventually forming a large-scale starting point. Around 2010, scientists discovered that older black holes had a new starting point. It is formed from the accumulation of previously fallen matter. This new starting point is relatively mild and produces weak tidal forces, so it's theoretically possible to survive here. But in order to prevent being caught up by another starting point, must dive into a black hole at close to the speed of light. The movie Interstellar. This is the basis for the advice given to Cooper by Ronald Lee Inn. There's a modest beginning inside the ancient Gargantua black hole. Cooper can survive by sneaking at high speeds. Although director Nolan depicts this possibility in a mysterious way, Cooper managed to accelerate enough to get to the start and survive. Although no one knows exactly what is at the center of a black hole, but in the movie we see, need to be explained by quantum gravity theory. Nolan's vision. When Cooper enters the starting point, it is transported to a 4-dimensional object, tesseract. It is thought to have been placed by higher beings that opened wormholes. A tesseract is a 4-dimensional cuboid. Each face is a 3-dimensional cube. Just like each face of a 3-dimensional cube is a 2-dimensional square. This structure allows Cooper to enter one of the sides, and eventually reach his daughter Murphy's room. It is worth mentioning that, if the journey seems to be quite rapid, despite the distance, that's because the Tesseract has been lifted beyond our universe, through the anti-God geometry we mentioned earlier, significantly shorten the distance. Once Cooper reaches his destination, the Tesseract is equivalent to an elevator leading to the fourth dimension. It is possible, because light can travel on the surface of the Tesseract to Cooper's eyes. But according to Nolan's camera model, light cannot travel from Cooper back to Murphy. Therefore, Cooper cannot communicate directly with it. However, once Cooper reaches gravity, he can pass through obstacles and convey messages. It is inspired by theory. In multidimensional space, gravity can span all dimensions, while other fundamental interactions are usually limited to our own dimension. Therefore, Cooper used gravity to transmit quantum data to Murphy, provides key information needed to solve equations. In this way, she became the mastermind behind the gravity anomaly. Although this is the rule Nolan set for this highly imaginative plot in the movie, but Murphy can use these data to master the method of controlling gravity, thereby reducing the gravity on the Earth's surface, send a huge space station into space, ultimately save humanity. Interdestruction of the space station as a giant centrifuge, able to make the necessary centrifugal force calculations and travel to Saturn through the wormhole. In a scene from the movie, we see a baseball player hitting the ball. The ball traveled through the space station and eventually broke the upper window. Looking from inside, the ball's trajectory seems to be curved, because the entire space station moves with the rotation of the centrifuge. Even though we don't know the exact speed of the ball, trajectory angle, parameters such as radius and rotation speed, but it can be seen from the movie that the gravity inside the space station is similar to that on Earth. This means that the space station's rotation rate must be precise enough to create this gravity. At the same time, we see a baseball passing by in scene 4. Break window after 6 seconds of flight. By analyzing frame by frame and comparing it to the size of the players, its exit speed can be estimated. We estimate the exit speed of the baseball to be 30 meters per second. Within the constraints of these data, the wheel radius of the space station is determined to be approximately 50 meters. The diameter is about 100 meters. Circumference is about 310 meters. At this size, the space station rotates 4 times per minute, can produce artificial gravity similar to the Earth's gravity. Although this is a relatively small site, however, by comparing it with the size of the building or using other methods to estimate, baseball's trajectory can be miscalculated, even get completely different results. Sometimes the error may be as much as 1 kilometer. These calculations and size estimates reflects the creative thinking of relativity experts, Interstellar, as well as stunning visuals and rigorous scientific research, bringing a profound experience to the audience. Through these calculations, we can more deeply appreciate the film's attention to detail and scene construction, and the exploration of hidden problems.